This is ENG1030. Thanks for coming in at 8 o'clock in the morning for the first lecture of the semester. My name is Jamie, and there are a bunch of other people important for the subject that we'll introduce a little bit later on. Is this anybody's first ever lecture at university? Oh, quite a few. All right. Well, if it's not too hard, can you... is it too hard to stand up? Maybe. Too hard to stand up. Stand up. Stand up. Shake the person's hand next to you or give them a kiss. Meet them and then wait. On the count of three. On the count of three, we're going to yell out, "I love Monash." On the count of three. And the louder we make it, the better, because everyone in the other lecture theatres is going to wonder what's going on. So on the count of three, I love Monash. 1, 2, 3. I love Monash! That was pretty good. All right, you can sit down. So you've met someone, exercised your vocal cords. That's all very good. Now I want to know why you're here. It's a multi-choice question, and we're going to answer it using an online system, using a phone or a tablet or your laptop. So if you've got those up, and don't turn off your phones, turn them on. All right? So why are you here? I'll show you how to answer in a minute. But the answer is A, you are or might want to study electrical and computer systems engineering. B, you had no other choice. C, you have heard that it is an awesome subject. Or D, you got lost on the way to the toilet. So, could be any of those. A, B, C, or D. I want to know. How do you answer? Well, you go to this website. This is going to be important because there's going to be potential assessment attached to answering questions that we pose in lectures. But there's a catch. It's okay if you absolutely do not have an internet-enabled device that you can bring into lectures, then there's another way of getting these marks. But if you have, well and truly worth going to this website, melts.eng.monash.edu. Hopefully you do know your Authkate username, and then your password is 12345. And you should be able to get into the system. So who's been able to get in so far? A few people, all right. We'll keep it going. I'll give you 30 seconds. And I'll show you at least what it looks like for me. So this is an online audience response system and more, and it was in fact built by some final year electrical and computer systems engineering students for their final year project. Has lots of different features. You can hit thumbs up or thumbs down at any stage during lectures. So there you go. You can do that if you're not understanding something. Right, and it's not anonymous. No, it is. You can ask questions. You should be able to get on there and ask questions in the lecture if you don't want to stick your hand up. You can put something in there online, ask a question. We'll look those up occasionally. There's a leaderboard for who's answered questions throughout the semester. I think I've put them in teams. I think you're in red and blue teams, and red and blue teams can compete throughout the semester so that there's quite a lot happening. For the moment, I'm going to start a quiz, and I'm going to ask that question. Why are you here? And it's open, and you should now see it on your screens and be able to respond. So, I thought I unlocked it earlier. Okay, so there it's unlocked, and you can start answering it, and I might hide it and then come back to it in a minute. So we'll have a look. So this is good practice for when we get to the real thing. All right, so then we'll say that's long enough. Let's go back there. Oh. Multi-window, so there we go. Look at that. Well, look. So there's the response. Already 93 responses. I think there are more people than that here. As I said, there's potential marks associated with answering these questions in class. And the good news is you don't even have to get them right. So the right answer in this case was D. You got lost on the way to the toilet. But it doesn't matter. Just by attempting it, just by attempting these questions, we record that your Authcode username has responded. And if you just attempt enough of them throughout the semester, you've got the potential to get 2.5 marks for this subject. How good's that? So more about that later. At some point I can lock it, so with say 104 responses, I'll let people still answer that one for a while now. So that's MELTS, so we'll be using it regularly throughout the semester. Why am I here? Well, that's an important question, and I want to start quite a long way back. I want to start in 1979. And the next quiz involves working out where I am in this class. This is grade 3. And I want to know, is that me? A, is that me? B, is that me? C, or is that me? D? So now I should be able to pose that question on MELTS. So bear with me. I'll do it online. Oh geez, that spoiled that. So if I back out, I think this should work. Sorry, this arrow. Get to use the system. May have given it away. Which grade 3 student am I? Was I student A, B, C, or D? I have to unlock it. There we go. I'll leave these ones. Normally I wouldn't leave it up because what you find is as if everyone's voting D, then everyone else starts voting D. You know, like if it's a question about how many amps is flowing through this part of the circuit. So I'll normally hide them until everyone's had a response. So student D, again, D is the correct answer. So very good. Very good. If I put this back up, I wasn't A, I wasn't B. Actually, I wasn't D, I am C. C there now. What on earth happened to my hair? I don't know. Happens when you get old. I used to be so cute. And then I go to grade 7, and I grew up in Newcastle, up in New South Wales. Where am I? The same place, exactly. There I am. Funnily enough, I was always on the outer, always on the edge. The hair's pretty much the same, but I'm starting to have no idea, a bit confused and dazed about what's going on in the world, getting that quizzical, inquisitive nature that clearly led me to studying physics and engineering at university. And there is my first day at university, and you can probably work out where I am there. And you'll also understand, here I am there. I thought I was pretty cool, and that also explains why I don't have many friends. So that was my first day at university, did computer engineering and physics, and many years later I'm now in electrical and computer systems engineering here at Monash. I'm head of the department. I've been in lots of other universities, Sydney Uni, University of California, Berkeley, and at University of Melbourne for 11 or 12 years before moving here a couple of years ago. My research is in telecommunications. You might associate that with electrical systems, but I want you just to take a minute, discuss with your neighbours. I want you to have an example of an electrical system if I ask you. So discuss, get something in your mind. You've got a minute to think about it. I won't absolutely cold call you. Think about it for a minute. Discuss, make noise. Examples of electrical systems. All right, let's go. Here, have you got an example for me? What's your name? Marcus, your example. The exit sign. I'm sure there's some electronics in that. Very good. Have you got an example? A clock? Very good. What sort of clock? Electronic clock. There you go. That does it say. And do you have an example for me? Lighting systems, maybe smart lighting systems, LED-based lighting systems. How about you, young man? A fridge. Excellent fridges, and now they're even getting smarter and being connected to the internet. What about an example here? Laptop, yes, and TV, and speakers, and just say anything, and you're pretty much going to be right, because if something's not entirely electrical, nothing is, but just about everything has an electrical component. Here's just a little bit of an example of things, and I think what's interesting here is the difference in scale. If you work in electrical, electronics, computer engineering, you might be working closer to what I'd call the sort of physicsy end, working on quantum mechanics or electromagnetism, and working at the micro scale with electrons, photons, EM waves, and so on. Lighting was already mentioned here, incandescent globes. Motors, LEDs was kind of touched on. Transistors, the heart of electronics. AM radios, digital watches, calculators, laptops, phones. So starting at the very small scale, but finishing down here with global communications networks that electrical engineers are a big part of designing and maintaining. And also, say, distributing power, generating power and distributing it to everybody's home. So these big statewide or nationwide power grids and telecommunications networks as well are a very important part of it. And that's probably where electrical engineering started to define itself. Everything is a branch of civil engineering pretty much. But at some point, people thought, oh, geez, all these power networks and the electrical telegraph started to define a new field to do with electrical engineering. But it's now a very, very broad field. Just to highlight that, there are 4 things you might not necessarily associate with electrical engineering. I have a bridge up there. It's a famous bridge in Greece, and it's perhaps the smartest bridge in the world. It has 300 sensors, electronic sensors, built into that structure so that the bridge can be monitored in every sense of the word. How's it vibrating? How's it swaying? What are the tension like? What's the humidity, the temperature? Whatever you want to sense, at 300 places throughout that bridge, constantly being sensed, fed back to some control centre to see, is this bridge behaving as we expect it to based on the design of it? So that smart bridge. Buildings these days and normally have more and more electronics embedded in them for monitoring and controlling things. And so smart buildings in general. There's a chemical plant. You might be budding chemical engineers. It'll be full of programmable logic controllers, things monitoring processes, measuring the percentage of this chemical or that in a process, and controlling based on that. So process control and electrical systems are critical to that. There's a robotic system, automation of manufacturing processes, electrical engineering key in sort of this mechatronics automation manufacturing area. And this one down the bottom is a bionic eye. So biomedical devices in general. Electrical engineering can play a key component. One of our big projects at the moment is a bionic eye project, which I'll tell you a little bit about later in the semester, happens to be led from electrical engineering. You've got to deal with putting electrodes on someone's brain and stimulating the optic nerve directly. But there's a lot of electronics involved in that. So very diverse. No matter what field of engineering you're interested in, electrical systems are going to be there and play an important role. I sort of summarised this semester. If you can fully analyse this circuit now, you really don't need to be doing this subject. By the end of this semester, though, you should be able to work out what on earth this thing is. At the moment, maybe the resistors are familiar to you, but the other... Oh, yes. Which one of them? There are two of them. Yeah. What are the capacitors doing? Yeah. That's not bad. What it is a bandpass filter. So one is a low-pass filter and one's a high-pass filter. So what this particular circuit does is you take an input. You might be interested in signals in a particular range. Say it's a radio station in a particular range around 774 kilohertz or whatever. You want to filter out all the other stuff. Any low frequencies or high frequency noise or whatever it is, get rid of it. And this is a circuit that will do that for you. A simple bandpass filter circuit. Resistors, we'll talk about in weeks 1 and 2. What's voltage, what's current, and what are resistors? That's week 1 and 2. So that's understanding, if you don't already, what these components are, what we mean by V for voltage and I for current and so on. And many of you will have already had some exposure to that, but certainly not all. So that's week 1 and 2. These things, as we've been told from, what was your name? Luke, up the back there, operational amplifiers. Very powerful devices that can be used for all sorts of things. You'll learn about those in weeks 3 and 4 and have labs playing with those components. This thing is called a capacitor. You'll learn about that in week 10. And then, importantly, to tie it all together, you need to know if I put sinusoidal input signals in, how does the output change as a function of the frequency of those sinusoids? And we do that in what's called phasor analysis. So it ties everything together at the end, and that's in week 11. So by the time you've got to week 11, you'll be able to tell me exactly why that is what's called a bandpass filter. But we need to know about all those basic components first. So the things we learn will be able to be pieced together to build very useful and important circuits. You'll learn, or you might be able to work out what that circuit does. You might already know. That's actually a taser or a stun gun. You know, those things that can zap people. I built one at home for when my mother-in-law gets out of control. It's come in very useful on several occasions. And you might even be able to work out what that circuit does. In fact, I usually give $5 to the person who works that one out for me as quickly as possible. So here are the unit staff. As I said, my name's Jamie. I am one of the lecturers, but we also have Jonathan down the front here, who is the subject coordinator and will be lecturing, I think, on Thursday this week and at various other stages throughout the semester, the op-amps and the digital in particular. We have PC, who's down the front here, and she is like the teaching associate or TA. What are you doing this semester? Staff. She's doing staff. Thank you. And Moses, who's doing everything associated with labs, the lab coordinator, is going to make sure that all the components there, that you don't lose all the cables, etc., etc., etc. So we're probably the main 4 people that you'll be interacting with, but there are a host of other tutors and demonstrators working with us on this subject as well. Where will you spend your time? Well, there are 3 lectures a week. Obviously, this is one to very many type of teaching where you try and paint the big picture, give the overview of the topics and so on, what's really important and such. But tutorials are where the ratio is a little bit better, maybe 1 to 20, 1 to 25 in the tutorials, so it is a better chance to ask questions and get some help with understanding something that you're not getting. You will get most out of them if you do questions before class. We, in fact, give out answers or solutions to the tutorial questions. So the point of going to the tutorials is clearly not just to get the answers or the solutions, because we hand those out anyway. So try and think of using the tutorials in a different way to make sure you're staying on top of the material. Hands-on stuff is also a really important part of it. You'll do some soldering, you'll learn how to use function generators and oscilloscopes and a range of different things, and we really do consider that a critical part of it. And in fact, there's a test on those lab skills in about week 10 of the semester as well. So we take that as an important learning outcome. Not just the theory, but also the practice. Now, there is a prescribed text, which is this one up the top here, Basic Engineering Circuit Analysis by Irwin and Nelms. We use it pretty closely. A lot of the material, a lot of the tutorial questions, they're actually taken from this textbook. I think it's about $140 in the bookshop, or it's free if you steal it from the library. Okay? Not that I would ever encourage that sort of behaviour. There's a ton of online stuff. Moodle is the primary resource. There are discussion boards. The recorded lectures will be up pretty much straight after each lecture. There are video introductions to labs, online lab preliminary work, and online quizzes are also, weekly online quizzes are a part of this subject, and they are assessed, and you do it all through Moodle. There's also something called Wiley Plus that comes with the textbook, and there are all sorts of warm-up quizzes and a lot of other resources at that website. You can go there if you buy the textbook. Okay, we give you access later in the semester whether you have the book or not. Oh, okay, there you go. Okay, for our own questions. There's also unofficial online stuff. So there is a Facebook group, ENG1030 Semester 1 2014. And of course, if you use Twitter, hashtag ENG1030, and I am at Slackademic. Just a brilliantly witty thing there. So let's have a look. If we scoot up there, we can see, oh look, there's Facebook. There you all are. 140 people joined up already. Jonathan, he's from last semester. Geez, why did I get those ads? We'll just skip that. Pretend you didn't see that. Something to do with my age and the fact that I'm in a complicated relationship, I think. So there we are. And Jono, I'll add you there now, mate. There you go. And I've got a contest for the most Facebook friends with my colleagues, so please friend me, and then I can win. And there, hashtag ENG1030. Not long before the very first hashtag ENG1030 lecture, hoping Monash Uni will retweet this. They don't normally retweet anything I say, mostly because it's rude. But I'm hoping that one gets retweeted. You can hashtag ENG1030. You can see it's going off. And let's have one. Let's try and have one before the end. Come on. Okay, well, I'll check that later. But, get on there, tweet it up, ENG1030. So that's the unofficial online stuff that people often find pretty useful. The unit guide's the be-all and end-all of everything to do with the subject. It's on the Moodle site, I think, from this morning. So you can get on there, download that. Tells you everything you really need to know, including the unit outcomes. So to successfully complete it, what are you going to be able to do at the end? I've already touched on this, but you should be able to analyse DC and AC circuits using appropriate methods. Should be able to analyse first-order circuits and do phasor analysis. So all that stuff will mean more as we go through. You'll learn how to use op-amps to build various types of amplifiers, inverting and non-inverting amplifiers, as Luke has mentioned. You'll learn some basic digital logic. How do you minimise logic expressions? How do you deal with zeros and ones? And in the labs, you'll create circuits using basic components, resistors, LEDs, capacitors. You'll physically build circuits using all of these components in the lab. We won't just talk about them in the lectures. So you'll analyse diagrams like the things up the top. You'll use these the scopes and the function generators, and you'll do some soldering of a little thermometer at the very end of the semester. So both the theory and the practice of electrical systems. It's not only the technical outcomes that are important, it's also the generic skills. Teamwork and communication come up again and again and again by employers as the things they really value. We want people who are good working in teams and also who can communicate. But I think probably more important is your personal hygiene, your understanding of Game of Thrones, and your love for this man, Daniel Wells. If you don't have a football team yet, I can recommend the North Melbourne Kangaroos. And this man, Daniel, my son is named Daniel, named after Daniel Wells. That's how much I love this man. My daughter, I had a daughter, and that became more complicated. So her name's Stephanie, but that's all right. It's named after Anthony Stevens, who was an ex-Kangaroos player. But please, if you ever see my wife, don't tell her that because she doesn't know. She doesn't know, all right? So it's just between us. All right, two kinds of students in this course. I'm sure there are more than two kinds. But some of you want to do electrical and computer systems engineering. Some of you want to do some other sort of engineering. And some of you are lost, as you say, as we said before. But I guess hopefully I've motivated before that regardless of what sort of engineering you're interested in, be it civil, chemical, mechanical, you're going to come across electrical systems, and some very basic understanding of what's going on will be useful, just so the electrical engineers can't pull the wool over your eyes, if for nothing else. So I hope it's a unit for everybody. As I said, electrical systems are everywhere. You get some hands-on skills, basic physics understanding, and general problem identification. So I don't expect you to be able to read the details here. I just pulled off a slide it's in the unit guide. Some of the important things for now are that tutorials start when? Next week, week 2. Labs start when? This week. So it's an induction lab this week. Everybody goes in week 1 to the lab. After that, you'll go every second week. So you'll have your next lab in week 2 or week 3, and that's allocated in the induction session. Moses, sorry, I'm looking at the wrong person. So you go along to your first lab, you learn about lab safety and various other things, and you get allocated to even or odd weeks, essentially. And then there'll be a lab pretty much every second week. 5 in total, I think, after the induction lab. Okay? So tutorials start next week, but you turn up to your lab session this week. Also, the first online quiz is due at the end of week 2, so you don't have to quite worry yet, but at the end of week 2, there'll be an online quiz. It includes not only material that we've already looked at, but stuff that's coming up. So we get you to do just a little bit of pre-reading on the stuff for the following week. So don't expect that you've already seen everything in those online quizzes. There's some really elementary stuff on stuff. I've said stuff a lot, stuff. Elementary questions on material from the following week as well. Up the top there, that is not 1 to 2 hours a week, it's 12. Let's just get that clear. If you want to do really well in this subject and understand the material, the expectation is certainly around 12 hours a week that you would spend on this subject. Obviously, that's not all one-on-one contact. Some of that's doing the online quizzes, preparing for the labs, preparing for the tutorials, pre-reading for lectures. That's what you should do if you're going to do really well. About 5 on average is contact. That leaves about 5 to 7 to be outside and in private study. Of course, it's entirely up to you. Your timetable will have the 3 pink slots there because they're the lectures. It'll have one of the green ones and one of the blue ones. And as I said, your green slot starts next week. Your blue slot starts this week, as well as the pink ones. Okay, so I'm really excited about this initiative. My department has a very close relationship with the North Melbourne Kangaroos, and there's Daniel Wells again. And this is especially good if you're slightly worried about how you're going to perform in the subject, because all Kangaroos members receive a 10% addition to their final mark for the subject. Okay, so if you can show me, bring it up, show me your North Melbourne membership card, I add 10% to your final mark in the subject. How good that's going to be if you got sort of 47 and you just, that Kangaroos membership comes good, 51.5, thank you very much. So keep that in mind, little extra feature. No other university has this arrangement. I can guarantee it's an exclusive for Monash and electrical engineering at Monash University. I used my connections to get that. Very, very happy with it. So what is the assessment? Well, 70% is a final 3-hour exam. Kind of a big chunk of it. But how are you going to do well in that? Well, it's by doing the 30% of the continuous assessment. That's made up of 12.5% from the labs, and that's got 2 components. 5 labs, each 1% each, and then the lab test worth 7.5%, where you go in by yourself, not with a partner, by yourself, and have to build a circuit, make some measurements. That's what you're going to have to do. So during the labs, you better learn how to use all the equipment. You better learn how to use breadboards, how to do all the things that are covered in those labs, because you'll be alone in the lab test. There'll be more information on that throughout the semester. But 12.5% labs. There's a mid-semester test in week 7 worth 8%. 7% weekly quizzes online, so they're 1% each for 7 quizzes. And something new for this semester, 2.5% participation. This is what I was talking about before. If you've already attempted 2 MELTS questions, you're well on the way. If you attempt 80% of in-lecture questions, you'll get 2.5%. Or, if you attend 8 of the 10 tutorials, at least, you will get that 2.5%. 2 different ways to get it. If you don't have an internet-enabled device, that's fine. You can still just get that mark by going along to 8 out of the 10 tutorials. But we've introduced this I guess because we think that engagement in the subject is the key to doing well. And that tends to mean turning up to stuff, having a go at stuff. And as the semester goes on, you might start thinking, of course I'm going to do that, but it gets a bit harder and harder to stay committed when no one's really keeping an eye on you. No one's really telling you, oh, are you going to lectures? Oh, are you doing this? Are you doing that? You're on your own. And so it's totally up to you. We've just got a little bit of an encouragement to stay committed with that 2.5%. Both of those are hurdles, by the way, the 70% final exam and the 30% continuous assessment. What that means is you have to achieve 45% in the final exam, at least, and you have to achieve 45% in the continuous assessment to pass the subject. You've got to pass both. You can't just do nothing through the semester and gun the final exam, and you can't have 30 out of 30 in the continuous assessment, but then only get 20% on the final exam and scrape through. It won't work. You've got to get 45% at least in both of those components. Any questions about that, what the hurdle means, how that assessment shapes up? So a lot of this stuff is worth 1%, and it doesn't sound like a lot, but it does add up. Most importantly, that's how you learn the material. So that's how you're going to do well on the final exam. So all these quizzes, 7 at 1% each, lab assessments, 5 at 1% each. Sometimes this stuff will seem like it's a lot of work for 1%, but keep in mind that really isn't the point. The point is it's by doing that is going to help you learn the material, which is going to help you do well on the final exam. So don't neglect these. As I say, only 1%, but you wouldn't want to forget every week. But every year we have people at the end saying, oh, I got 48 and I forgot the online quizzes. Is there anything you can do? And I say, no, sorry, it's a bit late at the end of the semester. So do these things, little things worth 1% each. Here's a little scatter plot of, here is questions answered in MELTs. So last semester we asked about 35 to 40 questions in lectures. And this is the number, how many the student attempted versus what their final mark was in the subject. Now, clearly it's a big spread, but perhaps what's interesting is that the average final mark for students who attempted less than 5 MELTs questions was 59%, and the average final mark for students who attempted more than 30 MELTs questions was 78%. So, of course, you can not attempt any of them and you can get 100% because that's fine. But on average, students who are engaged, participating, staying awake in lectures, whatever it may be, are doing significantly better than students who don't. That's why we've introduced this participation mark. One of the reasons. Okay, so the lab work has potential hazards. We need to ensure everyone is safe, as do you. You have to have some safety glasses. You can get them for $5 to $10. You can't do any cutting or soldering without these glasses on. Now, are there any questions about that? Can you get them in the Union campus building? If you've got normal glasses, is that good enough? No, because things can still fly up under your normal glasses, so everyone needs safety goggles, and everybody has to wear good footwear, which means you cannot wear, I'm not allowed in the labs because I've got these on. I cannot come and help you in the labs. I'm serious, I would not be allowed in. Moses or PC would kick me out if I tried to walk into the lab with these sandals on. You don't want to drop some heavy piece of equipment on your foot, basically, or have a solder burn your toe off or something. So we take that seriously. You will be not allowed to participate in the lab if the footwear is not appropriate. Is that right, Moses? That's right. Whatever Moses says goes. This will not work. Invisible safety goggles, we will not fall for. And this type of footwear, entirely inappropriate, even if you tell me it's leather. Okay. I've already touched on this a little bit. I have touched on it. Uni is very different to high school, because you're going to work out pretty soon that I don't actually know if you're in the lecture or not. We don't take a roll, and you turn up. No one's going to know. So you'll work that out pretty soon. And 8 o'clock Monday mornings will be interesting. So it's very different. You've got to drive everything you do. Nobody's looking over your shoulder now. Nobody. And it catches a lot of people out. That's the bottom line. If you haven't learnt to be very self-disciplined about things, this is a real danger. And most people that bomb out in first year, this is probably the reason. That you just sort of lose track, lose your way, have fun, which is excellent, and forget that you're here actually probably to study is one of the reasons you're here for. So it's very different. Keep that in mind, and we're happy to talk to you at any stage about the differences and help find out ways to help you out. There were the marks from semester 1, 2013, just so you get a bit of a sense of what the spread's like. Everyone, here it could be that 65's a pretty solid mark at university. Maybe you're used to getting much higher marks than that at school. But there was the percentage distribution. That's good. But it seems to happen to me every semester. I had a dream last night, and you were all in it. Don't get the wrong idea. It was all good. It's all. And this was my dream. And I seem to have this dream every semester. It hasn't quite happened yet, but the bottom line is any one of you could get a high distinction in this subject. You've got the capability to. I truly believe that all of you have the capability, so it's just up to you. If you want to put the effort in, if you participate, if you come to lectures, go to tutes, do all the continuous assessment, you will go well in this subject. There's no question about it. But it's not up to me, it's not up to John or PC or Moses, it's up to you. If you make it happen, I'll shave my head off at the end of the semester without doubt, unless the natural ageing process beats me anyway. That is it. Thank you for your attention and for coming in at 8 o'clock on a Monday morning. See you in the next lecture.